Dr. Reicks, appreciate your time today here, and looking forward for discussion. Thanks so much for your time.
Yeah, thank you for having me.
Good deal. So, if you can share your background and your career for those that don't know you, and then we can jump right into the, quality in boar studs right after that.
Sure. Well, I grew up on a pig farm in Iowa. We had like a 200 sow farrow to finish, which was a good big farm in those days, and wanted to be a veterinarian. I went to Iowa State University. I got a degree in animal science, and then got my veterinary degree also from Iowa State, and started in a larger swine practice. Was there for 22 years, and then about 4 years ago, I went off on my own. I kind of separated all of my business and started Reicks Veterinary Research and Consulting. So been doing that. I'm on my 4th year doing that. I do some management and consulting of boar studs. I oversee a company called Pork Storks. We have 4 boar studs in the U.S., and then there's 2 franchise boar studs in Australia that I work with. I do a lot of consulting, independent consulting for boar studs. And I have a veterinary andrology lab. We do semen analysis, like third-party quality control, bacteriology, benchmarking, and then we have a seminar, which is coming up here in April for people that participate in the lab. We've got a small research farm, very well located, and that's served me well. I've been able to do quite a bit of research there with different viruses, PED, done probably 7 or 8 studies with PRRS virus and boars, circovirus, Seneca virus, and then since I went on my own, I've started doing a lot of what I would call practical research, answering the questions that people in the boar studs want to know. I think the reproductive supplier industry has been faced with reduced margins since I started, and so I saw an opportunity there to do a lot of the research that 20, 30 years ago would have been done by those companies. They just don't have the funds now, and I guess I see it as my opportunity to give back. I do a fair amount of presentations. I've got 170 papers and presentations that I've given, and then also I've been very active with filtration since 2004, 2005, and set up a lot of farms there, do filtration design, biosecurity, auditing, and also with the ventilation. So yeah.
Very cool. Yeah, super extensive career in this topic, and it's so cool to see the very niched, right? I'm not aware, at least, of a similar type of consulting or company that has all this capability from the research side, from the lab side, on this very niche area, which are boars. So that's super cool. And so then the biggest question here is, which is the title of the webinar, is, and I've seen your outline, so I'll let you go here for a while, but the big question is, what are the key aspects, right, on ensuring quality in the boar stud?
Sure. Yeah, I think one thing which differentiates the boar stud a little bit is there's not really anything we can do to the sperm to make them more fertile than when they come out. And we can do things to get, better total born, better gain, better feed conversion. So with the boar studs, a lot of the things we do is focused on reducing risk. So first off, we want to avoid doing anything that's going to hurt fertility or going to limit the potential of maximizing fertility. So it's, in a way, it's kind of avoiding knockout items that could affect fertility. So one of the first things is, do we have enough sperm in the doses? And so just in my lab, we do a lot of boar studs send in a representative sample from each production day, and then we count how many sperm are in the dose. So the average is important, but just as important is the variation. So if you have a lot of variation from dose to dose, then you're going to have to put more sperm in there. So we calculate the average and standard deviation, and then I use that to determine what their targets should be on their sperm per dose. Basically, we're trying to avoid having individual sows bred with a dose of semen that doesn't have enough sperm, and that's going to limit the total born.
Very good.
So that's a really important aspect of the boar stud. The second thing is the morphology. So there's a lot of things that we can't routinely evaluate the sperm for before they leave the boar stud, but morphology is one thing that we can do. And we can look for the abnormalities real easy on each ejaculate, such as proximal and distal cytoplasmic droplets, distal mid-piece reflex, and detached heads. Those are common things that would be looked at that would reduce fertility. So like many things in the boar stud, we have cutoffs. So below a certain percentage, we know that that's going to affect fertility. So basically, we're trying to avoid outlier ejaculates. So a common cutoff with boar studs might be 75% normal morphology. So they count a certain number of sperm, or they may have a computer-assisted sperm analysis machine count, and then below a certain cutoff, the ejaculate would be discarded. Also with morphology is we can do tests to evaluate the integrity of the sperm cell membrane. So acrosome evaluation is a routine test that can be done on boar studs. It does take a little more time, 100x oil, and a phase contrast microscope. But there we can screen out, especially young boars. And with the trend towards more Duroc boars, it's a later maturing boar. It's important to evaluate the acrosome integrity. And again, we have cutoffs. So if there's boars that are below 70 or 75%, normally we would want to wait on using those boars until they mature. Most boars are going to be up in the 90s on acrosome integrity. The other use for acrosome integrity is post-production. And this is something I just started doing in the last couple of years. And is a good way to look for toxins or exposure to toxins or residuals that could affect the sperm cell membrane, but you might not pick it up with motility, regular motility evaluation. And then motility is kind of the old-time method that was used in the early days of boar studs and collecting semen and artificial insemination. It's a good screening test. It's fairly subjective, and but it is a test we also do at the boar stud and make sure we have good motility. There's certain bacteria that can affect the semen and result in pretty obvious bad motility. Also, some of the toxins, for example, exposure to gloves that have collection gloves that have residue. Often we can pick that up on a motility evaluation. So those are kind of the screenings that we would do on morphology.
Very good.
Viruses, we want to make sure the semen is free of viruses. Not something typically that we can do at the boar stud, but we can take samples. And that's been a big part of my career, is to evaluate the early infection period in boars, and to determine when we can first pick up different viruses. I started with a series of experiments in 2003 and 2004 with PRRS virus. And at the time, most boar studs were testing semen. And we showed that semen is a very poor sample to detect PRRS virus in boars early on in infection. And also boars shed intermittent. So we found that blood is the best sample. And we can pick up PRRS virus in the blood in 24 to 48 hours after exposure. Also done work with PED, circovirus, Seneca virus, looking at early detection. So most boar studs in North America, also throughout the world, would test for PRRS virus before semen is shipped. We can get a test result and then distribute the semen to the farms. One of the problems with PRRS virus and other viruses, Seneca virus as well, and likely foot and mouth, and the other related viruses to Seneca virus, is the boars shed in the semen before you see clinical signs. So the old kind of standard of closing the boar stud when you saw boars sick or off feed or with fever, it helps, but it doesn't really work with some of these viruses where they're shedding in the semen before they actually show clinical signs. So we have to find the right sample to test. In the case of PED or Seneca virus, it's feces. In the case of PRRS virus, it's blood. So that's an important part, making sure the boar stud is delivering semen that's free of viruses. If we move on to bacteria, we've kind of got a different situation with bacteria. There are certain bacteria that can transmit, but primarily, at least in North America here, we're worried about bacteria that can affect the fertility. One of the most famous, I guess, is Serratia marcescens. It's a bacteria that actually feeds off the sperm head and kills the sperm, and results in very low motility and very low fertility. Another bacteria that we're on the lookout always for is Enterococcus. Enterococcus fecalis is a bacteria. There's toxigenic strains and there's non-toxigenic strains. The non-toxin producing strains, they really don't do much. However, the toxin producing strains, while they don't really cause any damage to the sperm, they can cause like a toxic reaction in the sow and extremely low fertility. So those are some of the bacteria that we're looking for when we're culturing extended semen doses.
Let me ask you something there on the virus side of things, or maybe even bacteria. Any work on oral fluids there?
Yes. Yeah, oral fluids are a useful way to detect viruses. In the case of PRRS virus, there's about a 1-day delay between. So if in the studies I've done where we infected boars, typically if it's an aggressive strain, we'll find virus at 24 hours in the blood. We'll start to see virus in the oral fluids at 48 hours. There's typically about a 1-day delay. And then unfortunately, with the aggressive strain, we typically see virus in the semen about the same time that we see it in the oral fluids. So what I recommend is a combination of serum and oral fluid testing so that we still have a good sample size to detect it early, but we can use oral fluids as more of a population-based test, and to make sure that every area of the boar stud is tested, and that's how I use the oral fluids.
Very cool. Yeah, that makes sense.
So I guess moving on, some of the other things with ensuring quality is ventilation. The boars are not as resistant to heat stress and other stressors as they used to be. As we got more leaner genetics, we're seeing boars that go through heat stress at a lower temperature. So there's been a lot of boar studs have put in air conditioning. I worked and designed a lot of air conditioning systems with boar studs. When we do see heat stress or other stressors, something we've seen in the last 10 years and increasing is that boars don't recover from those stressors. 15, 20 years ago, we'd have a heat stress event. I would go to the boar stud, we'd take out the calendar, we'd mark 6 weeks later, which is about the length of a sperm production cycle, and we'd expect to see normal semen. And we'd get normal sperm and normal semen after 6 weeks. Flu outbreak, heat stress, any type of stressor, we could expect to see a return to normal production. We don't see that anymore. We're seeing the majority of the boars with permanent damage, and they just don't recover. I've had some where we've carried them out 6 months, 8 months, 9 months, and they just don't recover anymore.
Wow.
So that's a big change.
Yeah.
And I think a lot of us feel that it's just as we've focused more on growth, on the meat quality, and those types of things, the boars just aren't as tolerant to those type of stressors.
Very good. Yeah, that's super interesting. I remember learning about that wait month and a half, 2 months, but that's very interesting to know that doesn't apply anymore.
Yep. A new area that I've been working a lot with the last couple of years is toxins. And toxins is something I've been interested for a while, first with bacterial toxins. We do have, most places still have antibiotics in the semen extender. And for the most part, those antibiotics are targeted towards the gram-negative bacteria, a lot of fecal coliforms. So, however, there can be, some of those bacteria can produce toxins, even like E. coli can produce toxins. You might kill the bacteria, but the toxins are still there. That sort of led me also to wonder about different things we use in the boar stud lab, different cleaners we use. And there can be residues from lots of different cleaners that can damage the sperm. They might not hurt the motility. I've seen some cases where the motility was fine, but the acrosomes were damaged. And if we have a lot of acrosome damage, we can have extremely low fertility. So we've had some cases like that. So that's kind of a new area that I've been focusing some of my research in the last few years. Even some of the drying agents, powders or such as lime or drying agents that might be used out in the collection area, disinfectants. Some of those can be very toxic to the sperm, and others aren't as toxic. So I think that's an area of growth. Mycotoxins as well is sort of a big mystery. Not a lot of good research, very difficult research to do. But I had a case a couple of years ago with fumonisin, where we saw a boar stud go to about 40–50% discard rate from fumonisin in the feed. And so I think that's an area of interest I'd like to continue looking at in the future.
Yes. Super interesting.
One question, there was a question submitted about antibiotics in the extenders. So to date, most people are still using antibiotics in the extender. In some countries, there's a push to eliminate the antibiotics. Very difficult to do and very high risk to take the antibiotics out, because we have some bacteria that produce these toxins. And if we're not killing the bacteria, and we're using semen 2, 3, 4 days later, you know, they're incubating in the semen and producing toxins the whole time. Around 8 to 10 years ago, along with collaborated with Dr. Chris Custer, and we developed a technique we call the 3-glove technique and a free catch collection. And I developed some training modules with that, where it's a method where we actually dry the penis off, get the boar to full extension, and then we switch gloves and grab with a dry, clean glove and try to get the tip of the penis exposed, so that the semen goes directly from the tip into the collection cup. So that's something I worked on here the last few years. And we've shown that most ejaculates do not have any bacteria. It was always thought that raw ejaculate was heavily contaminated with bacteria, but we're finding with the free catch collection and the 3-glove method that we're able to get the majority of ejaculates with no bacteria. So that's something that we learned. There's a lot of kind of old wives' tales in the boar stud industry, and I like to take it upon myself to test some of those. As we learn, you know, more as time goes on, I think we've learned that challenging some of those established norms is worthwhile doing, because we're finding some of those things were not really accurate.
Very interesting. And I just want to jump in and share that we have those about 10 or 15 questions. I see Anna just sent one as well, and you covered one of them right on the antibiotics. One that I wanted to ask you, Dr. Reicks, is your thoughts on toxicity in plastics, especially packaging, you know, for the semen doses, and can that affect sperm quality?
Yeah, it definitely can. There was a big case in the U.S. A number of years ago, in Spain as well, and with plastics, with the packaging where the semen is in. So there can be adhesives. Some of the packaging has adhesives between the layers of plastic, and it was found that as time went on, the longer storage temperature, there was a leaching of different chemicals into the semen, and the plastics are a lot more porous than people thought, and that affected the fertility. So some of the plastic toxicity is very difficult testing to do. Typically you don't see any effect on motility. You may see some effect on acrosomes, but often not. So it's very important to work with a supplier that has good procedures and is doing toxicity testing. It really requires liquid gas mass spectrometry to identify some of those toxins. Badge is one of the toxins that was identified, and Magapor in Spain has done a lot of research with the University of Zaragoza and published a paper in Nature magazine showing some of the toxins. Other toxins, you can see the effect in the boar stud. For example, various gloves that are used for collection, whether it's nitro gloves, vinyl, or latex. There can be toxins on any of those. It was always thought that latex gloves were toxic to sperm, and they can be, but some are not. Some vinyl gloves, some nitro gloves can be toxic, and we can pick that up with motility checking. We do that at my lab. Boar studs and suppliers will send in different lots of gloves that are going to be used for collection. We do toxicity testing, and then we can approve certain lot numbers. So we've been doing that for quite a few years.
Interesting.
And then other toxins are, like I mentioned, different chemicals, cleaners that might be used in the lab, where the residuals, or might get cleaner on your fingers. Alcohol is a very non-toxic cleaner that can be used in the lab. Other chemical cleaners can be toxic.
Okay. One question I had here from the audience was on the packaging side of things. Can that affect the standard deviation of the concentration? I don't know if you have any data on that.
Okay, I think that question is related into package type. So traditionally, semen has been packaged in an individual dose. Originally, it was bottles, then went to tubes and cochettes, pochettes, or the blister type package. So with the individual dose, homogenization of the batch during dispensing is really important. So you can get a lot of variation from dose to dose if you don't have some method to homogenize the bucket of semen as you're dispensing. Often a simpler way of doing this is just stirring with a stainless steel spoon, and that will reduce the variation. When we get to bulk packaging, the dispensing is actually happening at the farm. So rather than having a big bucket of semen at the bore stud and homogenization happening there, the homogenization has to happen during dispensing at the farm. So just moving around. And we're in the process of doing some studies looking at variation. There have been a couple of studies out that showed a lot of variation from the first dose to the last dose with bulk semen. Other studies not showing any difference really. So there's a lot of variation there, but if you're using bulk packaging, it's important to realize that sperm are heavier than the liquid that they're in, and you need some form of trying to move that liquid around and keep those sperm suspended.
Interesting. Very good. We had a question from Quebec, Nick Codet. He asked about in our quality, in his boar stud, they're sending doses to a third party andrology lab. We observed some differences between the results and our own quality check on the same batch. Any thoughts on why there will be some difference there across labs?
There can be some difference. My lab is part of a group called CIVIL, Consortium of Independent Veterinary Andrology Labs. So there's 3 labs, Chris Custer Research and Consulting, and then Gary Althouse at the University of Pennsylvania. So quarterly, we compare samples between our labs just to make sure we're consistent in our sperm counts and our morphology and in our motility evaluations. If there's difference between the bore stud and the lab, I guess one of the advantages in the third-party lab is they're getting samples from a lot of different bore studs. So it enables, like at my lab, if we have a sample come in from a bore stud and their sperm counts are really low, the first thing I do is I look at other samples that were evaluated the same day from other bore studs. So we might have 10 or 12 bore studs that were samples evaluated on the same day. If all the other studs samples have the same sperm count that they typically have, but your bore stud is lower, then that gives us a lot of confidence that there's something going on at your bore stud. Likewise with bacteria, also with the morphology. So that's a huge advantage in a third-party lab that you don't have at the bore stud. But there can be mistakes made at the third-party andrology lab as well, but that is an advantage that they have. Sperm counts is probably the area where we most commonly see a difference. And the reason is that the equipment used at the bore stud to determine concentration is very repeatable, but it's not very precise. So whether you're using a spectrophotometer of some type or even a CASA machine, there's a lot of things that go into sample preparation, and that's pipetting technique, In the case of the CASA, loading the chamber properly. In the case of the spectrophotometer, the spectrophotometers are again very consistent, but not very accurate. So typically, what we do at my lab is we determine the concentration of the end product, and then we back into a calculation from there. For example, a lot of boar studs might target 3 billion sperm per dose. Almost none of those boar studs use a calculation of 3 billion at the boar stud. They might be 2.4, might be 2.6, 2.8, 2.9, 3.1. So we adjust the denominator to get the end product value that we want. And that's where sending in samples frequently is important. In the old days, we'd have people send in, 10 or 12 samples once a month. And that doesn't give us very good information. I'd rather get less samples more often, and we can see kind of where that boar stud is tracking. It gets especially important when we go to PCAI, and we want to keep the sperm count above a minimum amount. Maybe you decide you don't want to go below 1.5 billion. Well, we need to be monitoring that daily and looking at the average, but also the standard deviation to make sure we don't have individual doses below whatever your minimum is. So those are the things I would look at, I guess.
Very good. Yeah, very, very comprehensive. Another question, this one is from Giselle in Brazil. She's asking about long-term extenders, their main advantages or challenge, their economic viability of it. So what are your thoughts there?
Yeah, long-term extenders have been around for a while, and there's been improvements for sure made, in the last 5 to 10 years with more inclusion of antioxidants has been the biggest change. The biggest advantage with the long-term extenders is that you have more buffering ability, more ability to deal with differences in osmolarity, and also with temperature variation. So especially if shipping semen overnight, or if you're dealing with extreme climates, the long-term extenders are going to be able to handle adversity a lot better. As far as getting to a once a week or once every 2 week, I think the extenders have that ability, but I don't really see the industry going there. There's just too much risk. There's too many things that can happen. A semen saver or colatron gone bad on the farm. Someone takes the semen out and forgets to put it back. The semen saver's not in an area where the temperature, where it can handle temperature extremes. Temperature variation in transit, bacterial contamination. If we go out to where we're only delivering semen once a week to the farms, there's 7 days when something can go wrong. If we're delivering 3 times a week, there's only 2 or 3 days of production at risk when something goes wrong. And it's not a matter of if something goes wrong. Eventually, something is going to happen that's going to reduce the fertility of that batch of semen or that delivery of semen. And if we got 7 days at risk, there's going to be a lot more financial loss than a 3 times a week delivery where we only have 2 or at the most 3 days of production at risk. The other thing that's happened in the industry over the last 10 years, I think, is just the logistics. You go to other countries, just the roads are better. The ability to get a product from one place to another within 1 day is just way more feasible in way more places than it was 10 or 15 years ago. I think that's sort of, in a way, sort of reduced the need, to have a extender or once a week delivery. It would be nice. The boar studs would love it. There'd be less testing cost, but I just don't see it at this point. There's just too many days of production at risk.
Interesting. Very good. Anna De Souza has a question about on that. You mentioned about the heat stress and the boars not recovering. She was asking about if you have any thoughts on why, or because they're leaner, or any hypothesis there.
Well, I think it's an area of research that's needed. We probably need to pull some semen out of some of the frozen supplies and make some boars from that are being stored in frozen semen from 30 years ago and do some studies. But I think it does make some sense. Overall, there's been a trend towards reduced quality in morphology on certain lines. Anytime you're selecting for non-reproductive traits repeatedly over years and years and years, something's got to give, and typically it's going to be reproduction. Very few companies are including morphology or motility or sperm quality in their selection index. And I think it just makes sense that over time we selected away from fertility, and also selected away from toughness, and the ability of the testicle to respond to adversity. I think it makes sense, and unfortunately, it's got to the point where we got to design these studs now to be air conditioned, and we can't handle the type of we can't expect them to recover like they used to. Also, we have purebred boars. The trend, many countries trend towards a purebred Duroc boar. 10, 15 years ago, there was most of the boars and studs were synthetic lines. They might be a Pietrin based, or a Duroc based, or a Hampshire based, but in reality, they were really synthetic lines that were a combination of different breeds. Mm-hmm. And we have hybrid vigor and heterosis. Now, a good chunk of the world is using purebred Duroc boars, and we can't expect the same resiliency out of a purebred animal.
Very good. We do have a few more questions here. Before we get there, just want to thanks MB Swine to putting together this webinar that we are organizing here, and I also dropped their website here on the comments. They are putting together swine reproduction database on the website there. One question is, I think we have two questions left here, and then we can head to your flight there, Dr. Reicks. One is, what measure do I have to take in my boar stud if it broke with serratia?
Yeah, good question. Very hot topic. In the past, we were able, in certain countries, able to use Ceftiofur or even Enroflox in some areas in the extender during an emergency. A lot of areas we can't do that anymore, and also just a push towards reduced antibiotics. So serratia is something that has popped up. Those of us working with boar studs kind of knew that would happen. So I'm not sure there's really a break of serratia in a boar stud. My current thinking is that it's in the boars. It comes with the boars. I did a study last summer, kind of the search for serratia in a way, and surprisingly, we really don't find it in the prepuce. So I'm not sure it's either coming from the environment or the feces is my current thought, but it can be, it grows extremely fast. In my lab, a serratia contaminated sample, the culture plate's chock full of bacteria within 12 hours. And that's what it does in the environment also. And it kills sperm. So we got a lot of bad things happening for us there. Collection technique is extremely important. That 3-glove method, keeping prepuce hairs clipped short, using the 3-glove method, trying to do that final grab with a dry penis, clean glove, and having the tip exposed so that the semen can go directly from the prepuce into the cup. is a really good way to control serratia. In the lab, when we get it in the lab, it's not the toughest of bacteria in the lab. It's not a super good biofilm former like others are, but it's pretty good. It's good enough, and it grows really fast. So once it gets in the lab, it can be problematic. You know, doing a total cleaning of the lab with biofilm remover is really important. Lab detergents are really effective at removing biofilm from the lab. You know, just cleaning everything, switching tubing frequently, washing hands frequently, and just top to bottom, cleaning everything in the lab with biofilm cleaner, like lab detergent. Also, just minimizing the amount of material you have in the lab. In the old days, some of these labs would have all kinds of drawers, cabinets. We'd be storing tons of stuff in the lab. You know, nowadays we're trying to store materials out of the lab and have the absolute minimum amount of materials in the lab, so that you can clean a lot more effectively that way.
Interesting. Another question from Nick Coday again here about the article from Dr. Billy Flowers. Should we consider spermatozoid with distal droplets as normal, or what's your opinion about that?
Okay, so cytoplasmic droplets, every sperm has a droplet. It's actually the cytoplasm that's being expelled from the head, and essentially you're left with DNA then. As the sperm migrate through the epididymis, this cytoplasm is supposed to migrate from a proximal position where it's basically touching the head to a distal position on the midpiece, and then during ejaculation it's supposed to fall off. A trend we've seen with certain lines especially is that much more higher percentage of sperm on certain boars with a distal droplet. We're not sure why, but I don't believe it has anything to do with collection frequency. If you read some of the older literature, there was a lot of literature talking about collection frequency. If a boar was collected too often, you would actually draw more immature sperm from the tail of the epididymis. But I don't see that. We really don't see that anymore. There's something with these sperm. There's some reason why these cytoplasmic droplets aren't falling off like they should. When they're in lower amounts, I don't think it has a big effect. And I've always thought that, you know, you kind of got to look at a baseline level. In my lab, an average ejaculate has 10 to 15% distal droplets. And that's kind of a normal, the new normal for distal droplets. So if you're seeing those kind of numbers, I don't think you're going to see any effect on fertility. If you're seeing high numbers, you know, we really don't know for sure, but I still don't think those ejaculates should be used. If you're getting up over 25 or 30% with cytoplasmic droplets or distal midpiece reflex, you know, if you're using high enough sperm counts, maybe you can get by with that, but I don't think it's really worth using those because we don't have enough information at this time. There's something not happening normal in the development of that sperm, and especially with the proximal droplets. We know that there's probably also other issues with that sperm. There's probably something wrong with the DNA, and it's going to lead to the embryo death. Even if it does fertilize, there's something wrong with the DNA. It's going to lead to cell death and reduced total born. With the distal droplets, it's further along in the process. We don't know for sure, but I still think there's a high numbers of distal droplets. We shouldn't be using those ejaculates.
Super interesting. So we reach here 45 minutes. I do have a last question as a reward here for everyone that is stuck all the way to the end, and it's we have 30 plus boar stud enthusiasts and right here with us today. So what would be something that they can go tomorrow to the boar stud and apply? That's something that you know it's a very common mistake, but they can also apply and improve their production in one day.
I'll give you two things. I think keeping boars on a schedule is really important, a lot more important than it was, 15, 20 years ago. Don't mess around with the boar's schedule. They want to keep it consistent. Don't cause any insult to the testicle with stress by changing their collection schedule. The second thing in the barn is collection technique. Use a paper towel to get the boar to full extension. You can roll off the glove and paper towel and very easily grab just above and slide down the penis and be collecting the boar with a free catch collection. On most of the boars, you can do that. That dramatically reduces the amount of bacteria in that raw ejaculate and the toxins. So that's a good way to reduce the load of bacteria coming in with the raw ejaculate.
Very good. Well, thanks so much, Dr. Reicks, for all this knowledge that you share with us today. Thanks MB Swine for sponsoring this event here, this webinar. And thanks everyone for joining us this evening. Safe travels there, Dr. Reicks.
Thank you very much. Thanks to everyone who attended.
Thanks. Have a good one, guys.
Yep.
Bye-bye.
Yep. Bye-bye.